Group in periodic table. The group in periodic table are arranged not only according to the general trends in periodic table, but are also arranged according to the chemical properties of the elements. The elements of a specific group have the same chemical properties. The reason is because they have the same number of valence electrons or the number of electrons in their outer shell. Group 1A or Group 1 are also known as alkali metals. In the periodic table, they are the elements lithium, sodium, potassium, rubidium, cesium, and francium. You may wonder why hydrogen are not included as an alkali metals. It is true that hydrogen does have one valence electrons in its outer shell. The reason that it was not considered as an alkali metals is because it does not have low ionization energy and are capable of bonding itself or to form a diatomic molecules. Now, let's proceed to the characteristics of alkali metals. Alkali metals are highly reactive metals and have the largest atomic radii or atomic size. If we're going to follow how the periodic trends work, the element that have the largest atomic radii or atomic size is the element francium. Alkali metals are also low in melting points, densities, electronegativity, and ionization energy. They also have one valence electron or one electron in their outer shell which they lost during ionic bonding with other elements. Group 2 Family A are also known as alkaline earth metals. In the periodic table, these are the elements beryllium, magnesium, calcium, strontium, barium, and radium. Characteristics of alkaline earth metals. Alkaline earth metals are very reactive due to their two valence electrons or two electrons in their outer shell. They also have high melting and boiling points. They are also low in density, electronegativity, and electron affinity. Both alkali metals and alkaline earth metals have the largest atomic radii or atomic size. Group 3 Family A are also known as boron group. In the periodic table, these are the elements boron, aluminum, gallium, indium, thallium, and then the mu element nihonium. Characteristics of boron group. The elements in boron group are refractive and is common in reducing agents. They are also all solid except boron because boron is metalloid. They also have 3 electrons in their outer shell. Thallium can use one valence electron during bonding. Nihonium is excluded because it was a radioactive element that makes it hard to study and research by the scientists. Group 4 Family A are also known as carbon group. The elements in carbon group are carbon, silicon, germanium, tin, lead, and the mu element flerovium. Characteristics of carbon group. The elements of carbon group are stable and fairly unreactive. They also conform well to general periodic trends. There is also a decrease in ionization energy. That is why carbon group are commonly used in covalent bonding. They also have 4 valence electrons in its outer shell. During bonding, they can either share 4 valence electrons or 2 electrons. Except Flerovium, because just like nihonium, flerevium is a radioactive element that are hard to study and research by the scientist. Group 5 Family A, or the nitrogen group. The elements in the nitrogen group are nitrogen, phosphorus, arsenic, antimony, bismuth, and the mu element moscovium. Characteristics of nitrogen group. The elements in nitrogen group have 5 valence electrons except for the element moscovium, because moscovium is a radioactive element that makes it hard to study by the scientist. There's also an increase of their boiling point. Their ionization and electronegativity is also low. Group 6 Family A, or also known as chalcogens. Chalcogens comes from the Greek word chalkos, which means ore former. The elements under chalcogen are oxygen, sulfur, selenium, tellurium, polonium, and the mu element livermorium. Characteristics of chalcogens. The elements under chalcogen have 6 valence electrons. Except livermorium, they can participate in covalent bonding or gain 2 electrons. They also have low ionization energy and electronegativity. There's also increase in their melting and boiling point. Group 7 Family A, or also known as halogens. Halogens comes from the Greek word halos, which means salt former. The elements under halogens are fluorine, chlorine, bromine, iodine, astatine, and the mu element tennessine. Characteristics of halogens. The elements under halogens have 7 valence electrons and very active. If halogens are bonded with alkali metals, they form salt. They also have low melting and boiling points. According to periodic trends, the element that have the high electronegativity is under halogens, which is fluorine. Halogens focus more on receiving electrons than sharing. Take note, tennessine are excluded because it is a radioactive element and still does not have enough study or research. Group 8 Family A, or also known as noble gases. The elements under noble gases are helium, neon, argon, krypton, xenon, radon, and the mu radioactive element oganesson. Characteristics of noble gases. Noble gases are unreactive and stable because they have no valence electrons or have the maximum number of electrons in its outer shell, which is 8. They also have closed subshells except helium, because helium only has one s shell closed with 2 electrons. Due to its stable characteristics, it has low electronegativity, but helium is considered to have the highest ionization energy, except, of course, the radioactive element oganesson. Transition metal. The elements under transition metal are found in the middle part of the modern periodic table of elements. They are found between the alkali earth metals and the boron group, from scandium to copernicium. Characteristics of transition metal. The elements under this group are all metals, and most of them are hard, strong, and lustrous. They are also good conductor of heat and electricity. They also have high melting and boiling points. They also have valence electrons in two shells instead of one that can participate in the formation of chemical bonds. Lastly, we have the rare earth metals. The elements under rare earth metals are divided into two. The elements under lanthanides, from lanthanum to lutetium, and the elements under actinides, from actinium to lawrencium. Now, let's differentiate the two rare earth metals, lanthanides and actinides. Lanthanides fill the 6s2 sublevels while filling up the 4f. Actinides, on the other hand, have filled the 7s2 sublevels. The elements under actinides are also all radioactive elements, while lanthanides are not and have magnetic properties.